let's try to understand this word problem and solve it. Well, the first part is to read it carefully. The question says, Peter cycles 5 kilometers to return a friend's bicycle, then walks home. The entire trip takes 1.5 hours. Peter cycles 4 times faster as he walks. How fast does he walk? Okay, so we have a distance and time relationship. Okay, I hope you remember distance time triangle. Distance time triangle is something like this. Now here, distance is equal to speed into time, correct? So that's a triangle. So we say distance is speed into time, and speed will be distance divided by time, and time will be distance divided by speed, and that's how these three things are related. Okay, now in the given situation I prefer to make a table and then work my solution through. So let's make a table here, right, and see how we can solve it. So I just made a grid, not really knowing what I'm going to put where. Okay, but now we'll think about it. Now what do we have here? Peter cycles 5 kilometers to return friend's bicycle. So the distance covered by Peter is 5 kilometers when he cycles. Then walks home. Then, okay, so walks home the same distance, of course. So 5 kilometers is distance return. And the entire trip, so going and coming, takes 1.5 hours for Peter. And Peter cycles 4 times fast as he walks. So he cycles much faster. 4 times, okay. So basically we know we have distance, speed and time. How fast does he walk? So you want to find the speed of walking speed, okay. So let's say that here we write distance here, okay. So distance d, and we'll put distance in kilometers. Okay, and let's say we have speed s in kilometers per hour, and time will be in hours, correct? Now one way is to see like this. So Peter returns to a friend, so a cycle. Let's say he goes cycling and walking, correct? So let me put, because I want how fast he walks, let me write walking first, okay? So let's say when he walks, he has to walk 5 kilometers back. So it is 5 kilometers here, and the speed is, let us say, x. If you walk with a speed of x kilometers per hour, how much time will be taken? Time is distance divided by speed, and therefore it is 5 over x. Okay, now let's say he's going to the friend's place and he cycles. So when he cycles, then the speed is 4 times. So Peter cycles 4 times faster as he walks, so the speed is 4 times x. Is it okay? Distance covered, of course, is the same, 5 kilometers, and if you are cycling at a speed of 4x, then the time taken should be 5 over 4x. Perfect. So we get this kind of a table here. Now it says the entire trip takes 1.5. That means if you add this and this, you get 1.5. Well, that gives us our equation, and the equation is 5 over x plus 5 over 4x equals to 1.5 hours. Correct. You could have written this in fractions, 1.5, which will be 3 out of 2. Okay, let's write like that, 3 over 2, right? Perfect. So this is our equation which we need to solve. It's not a very difficult equation. It's in single variable, not much of a problem. Why it is under the habit of in the topic of rational functions? Rational functions, because we have variable here in the denominator. Do you appreciate that part? So x cannot be 0. He needs to walk to do this work, right? X cannot be 0. That's the restriction on this equation, right? And it's a rational function because you have a variable in the denominator, right? So let's try to solve this problem. Now we'll write the equation again. It's 5 over x plus 5 over 4x is equal to 3 over 2. Now when we have equation like this and so many terms in the denominator, it's a good idea to get rid of denominator. How can we do that? We can do that by multiplying by a common denominator. So So here x and 4x and 2, so the lowest common denominator works out to be 4x. So what we can do is we can multiply each term by 4x, right? So we multiply each term by 4x. Do you see? Times 4x. Once we do that, we can simplify and write it without fractions. So if I do times 4x, x and x will cancel, and 4 times 5, I'm going to get 20 here. Plus here 4x will cancel, and I get what? Just the number 5. How about this? Here 2 goes 2 times in 4, and so we get 2 times 3 as 6x. Perfect. So we get 20 plus 5 is 25 equals to 6x. Now we can divide by 6 both sides, and once we do that, we get 25 divided by 6 equals to x. Perfect. So the speed of walking is 25 over 6 kilometers per hour. Perfect. Now we are in a position to write down the answer, right? So answer is that Peter walks at the speed of 25 over 6, don't forget the units, kilometers per hour. Correct? So that's the walking speed of Peter. Correct? If they want to find even cycling speed, we'll just multiply this by 4 and get the cycling speed. Correct? I hope this was a very simple problem, but it's a basic problem to deal with for distance, speed and time, and gives you good concepts and way to solve. Don't forget to make a table which gives you the relation between the 3 variables, and this table gives you the given data organized manner and makes you see the problem, visualize it, right, and help form an equation. Did you see how easily we could come up with the equation? At times this could be very tricky. Okay, I hope you enjoy the process and learn a bit from here. Thank you.